Hi everyone! Today let's talk about sessions 12.1 Planes and Surface. Planes in space. To describe the tilts of a plane in space, we specify a vector that is normal or perpendicular to it. Consider the plane that passes through a point P with coordinates A, B, C with normal vector n equals n1, n2, n3. Let Q, x, y, z be an arbitrary point in space. Consider the following two scenarios, when Q lies on the plane and when Q does not lie on the plane. So you can see here, Q is on the plane. Okay, and you see here, Q is not on the plane. Okay, so when written in the component form, what is the vector PQ? So this is the vector PQ. Okay, so PQ equals, we use the terminal point, subtract the initial point. X minus A, Y minus B, Z minus C. When Q lies on the plane, what can you see about the normal vector and, the vector n and the vector PQ? They are perpendicular, they are orthogonal. Okay, so they are orthogonal or perpendicular. Okay, so n dot PQ equals 0. Okay, and when Q does not lie on the plane, N and PQ, they are not orthogonal. So N dot PQ is not 0. So that's why we come up with the Cartesian equation for the plane. The point Q, Y, Z lies on the plane even only if N dot PQ equals 0. Okay, and N is N1, N2, N3. Dot PQ is X minus A, Y minus B, Z minus C. Okay, so we get N1 times X minus A plus N2 times Y minus B plus M3 times Z minus C equals 0. Okay, and we say N is the normal vector of the plane. Okay, because it's orthogonal, it's pointing outside of the plane. Alright, let's continue. Parallel and orthogonal planes. Suppose two distinct planes have normal vectors n1 and n2 respectively. If two planes are parallel, what can you say? So this is one plane, this is another plane, this is n1, this is n2. What can you say about n1 and n2? So two planes are parallel if and only if the normal vectors are parallel. And what does that mean? It means one vector is a scalar multiple of the other one. Okay, so for some k is a real number. Okay, so it belongs to a real number. The two planes are orthogonal. Okay, what's the picture if they're orthogonal? So let's see. Let's say this. Then this is n1, this is n2. What do you say about their normal vectors? They're also orthogonal, right? So this means n1 dot n2 equals 0. Alright, so keep this in mind. Let's continue to look at the following examples. Find the equation of a plane with the given properties. It has normal vector 2, minus 1, 3, and passes through 1, negative 2, and 5. Okay, so keep in mind, normal vector will contribute to the coefficients of x, right? And this guy will be, okay, so we have 2, and then we have x minus the x coordinate of the point, 1. And then we have -1 times y minus y coordinate of the point, -2, plus 3 times z minus 5 equals 0. Okay, and let's continue. So 2x, let's distribute it. This is minus y. This is, it becomes plus 2, but there's negative in front, become minus 2. And here we have 3z minus 15. So please move all the constants to the right hand side. So here minus 2, minus 2, minus 15, that's like minus 19. But when we move the minus 19 to the other side, it becomes 19. Okay, so when I ask you to find the equation of a plane, please write it in this format. Okay. So you have x, y, z linear combinations on the left hand side, and the right hand side is the constant term. Okay. B, it is parallel to the plane and passes through 1, -2, 5. So given a plane, how can we find a normal vector? Okay, so the normal vector is going to be the coefficients of each variable. So that is 4, 1, and -2. Okay, so because our new plane is parallel to the plane, so you can actually pick the same. You can actually pick the same normal vector. So you know, the fact is, if you pick a constant multiple, let's say if you pick 4a, so let's use 4k. If we pick 4k, x minus a, and sorry, okay, let me make it general. So if instead of n1, n2, n3, you want to pick n1k, n2k, and n3k. You just have the same plane, because you can just divide it both sides by k, and then it's just gonna be the same. Okay, we can divide it both sides by k, and then we will get the same results as before. Okay, so so instead of constant multiple of n, you can just assume that our normal vector, you can use this n as well. Okay. So now we have the normal vector, we have the points on the plane, then we can write down the plane equation. So 4 times x minus 1 plus 1 times y minus -2, so y plus 2, minus 2, z minus 5 equals 0. And let's distribute it. So we have 4x, y, 2z. How about the constant? Minus 4 plus 2 is minus 2. Minus 2 plus 10 is 8. But when we move the 8 to the other side, it becomes minus 8. So this is our answer. So far, so good, everybody. Let's continue. It is parallel to both vector and passes through that point. Okay, now we have a plane. It is parallel. It is parallel to V and W. What do you say? Okay, what do you say? The normal vector is orthogonal to V and is orthogonal to W. Can you find a vector that is orthogonal to V and W? Any guess? Cross product. Yes. So we can pick the n be the cross product. Okay. So actually, the normal vector, you can pick any normal vector. It could be any multiple of this normal vector. Okay, so it could be v cross w or w cross v, or it doesn't matter. Okay, so you pick it. And what is that? Well, I j, k, and we have 2, 2, 3, 4, 1, minus 2. And the I, we have 2, 1, 3, minus 2. So plus, minus, minus j. And then we have 2, 4, 3, minus 2. So I hope you're familiar with calculating the determinants. Okay, so each time we delete the corresponding row and column and get the minor determinants of the submatrix. Okay, so this is I. 2 minus, so 2 times negative 2 is negative 4, minus 3 times 1, 3. 2 times negative 2, negative 4, minus 4 times 3, 12. 2 times 1, 2, minus 4 times 2, 8. Okay. Negative 4, negative 3, minus 7. Negative 2, 4, negative 12, minus 16. But there is a negative in front of it, so that is 16. 2 minus 8 minus 6. So this is the normal vector, and we also have a point on it. Then we have minus 7, x minus 1, plus 16, y minus negative 2, so y plus 2, minus 6, z minus 5. And that equals 0. Let's multiply out. 7x plus 7, 16y plus 32, 6z plus 30. So we have minus 7x, 16y, 6z. Okay, what are the constants? 7 plus 32, 39, 39 plus 30, 69. But when we move to the other side, we change the sign in front of it. So it becomes negative 69. So far, so good, everybody? Okay. You can also say 7x minus 16y plus 6z equals 69. Or you can use this. Same thing. So far, so good, everybody. Let's continue. Sometimes it's really good to draw pictures. See? Look at this example. It contains 3 points. Oh, okay. So it contains 3 points. It contains A, B, C. Okay, so your graph not need to be very accurate. You don't need to measure, okay, where is A located in the space. So just draw a graph, a picture, a plane, and we have 3 points on it. How can we, so we need to find a normal vector. How can we find a normal vector? Wow, you can construct 2 vectors here. And then a normal vector will be perpendicular to both of the vector AB and AC. Okay, so what is AB? We use the B minus the A. So 4 minus negative 1 become 4 plus 1. Negative 2 minus negative 1 become negative 2 plus 1. Oh, let me make this problem more interesting. Let me change this guy to 2. Okay. Then we have 7 minus 8. So that's 5, 3, and negative 1. How about AC? Well, we use C minus 8. So 1 minus negative 1 is 1 plus 1. Negative 2 plus 1. And 5 minus 8. So that's 2 minus 1 and negative 3. Okay, and then like what we have done before, we can let n be the cross products of them. Okay, that's I, J, K. 5, 3, minus 1, 2, negative 1, negative 3. Okay, so plus, minus, plus. So I, what's the sub matrix? 3 minus 1 minus 1 minus 3, right? What is the submatrix? 5, 2 minus 1 minus 3. So I hope all these examples, you can try the problem first, and then after you're done, you can continue to check your work, because I really hope that you have a lot of exercise with it. Okay, so we have 3 times minus 3 is negative 9, minus 1 times minus 1, which is 1. 5 times negative 3 is minus 15, minus 2 times negative 1 is minus 2, so it becomes plus 2, plus k. 5 times minus 1, minus 5, minus 2 times 3, 6. So minus 1 minus 9 is negative 10, minus 15 plus 2 minus 13, but there's a minus in front of it, become 13, minus 5 minus 6, minus 11. Alright, so we have the normal vector and we have the point. You can pick any points. Let's pick C because we have used it a lot, right? So let's do it. Actually, you can use any points. Okay, you can use point 1, point A, point B, or point C. It will give us the same plane. You can try that. So x minus 1, y minus negative, so it become y plus 2. And then z minus 5. Okay, now what happened? Minus 10x plus 10 plus 13y plus 26 minus 11z plus 55. I hope that you are, when you work on these problems, I hope you did not use your calculator, okay? Try to build up the sense with numbers. You can use your calculator to check your answer after you're done, but in the process of writing the solution, try not to use your calculator, okay? So minus 10x plus 13y minus 11z equals, so 10 plus 26, 36 plus 55. Wow, the answer is 91. But when we move to the other side, it becomes negative. So sometimes if you don't like the coefficient of x is negative, so we can flip the sign. We can multiply by negative 1 on each term on both sides, right? Then you can just pick this one. So this is our equation of the plane. So far so good, everybody. Let's continue. It is perpendicular to the line. Oh, so look at this picture. We have a line. The plane is perpendicular to it. Can you find the normal vector? Yes, it's in the same direction as the line, right? So how do we find the line? Well, the line, the direction of the line is the coefficient of t. Oops. The coefficient of t, you see, is 3, 5, minus 7. So far, so good. And the plane actually passing through the line at the point t equals 1. So let's see. Gamma of 1 is 3 plus 10, 5, and minus 7 plus 1. So that's 13, 5, and negative 6. So this point is going to be on the plane, right? So we have the normal vector. We can pick the normal vector n equals v. Then we also have the point on the plane, which is this gamma of 1. So the plane equation, 3 times x minus 13 plus 5, y minus 5, minus minus 7, and z minus negative 6. So z plus 6. 3x minus 39, 5y minus 25, 7z minus 42. So 3x plus 5y minus 7z. Okay. So negative 39 minus 25, that will give us 64, right? Negative 64. 64 and 42, 106, but it's negative 106. But when we move to the other side, it becomes positive 106. Okay, so this is our answer for this part. So far, so good, everybody. Let's continue. Find an equation of the line of intersection of two planes. So we have two planes. So they intersect. Okay, and we want to find this line. Alright, so it means we want to solve the system of equations x plus 2y plus z equals 5, 2x plus y minus z equals 7. Okay, so we want to eliminate one of the variable. Let's say we want to eliminate z, because looking at the coefficient, it looks like eliminate z is easier. Eliminate z. Then we add equation 1 and 2. We have 3x, 3y, z cancel, 5 and 7 is 12. Oh, we can simplify the coefficient because we can divide both sides by 3. Then we have x plus y equals 4. Okay, now you know, for a line equation, x, y, z is a function of t. So you can let x be t or you can let y be t. Doesn't matter. You have the same line. Okay, maybe the parameterization is a little bit different, but they all represent the same line. So let's say we let y be t, then x is 4 minus t. Okay. Then what is z? So we can plug in either equation 1 or equation 2. Let's plug in 1. Then z equals 5 minus x minus 2y, right? We can move the x and the 2y on the other side. Then now we can plug in x is 4 minus t. Don't forget your parentheses, because without the parentheses, it will be wrong. So 2y, y is t. 5 minus 4 minus negative become plus t minus 2t. Well, 5 minus 4 is 1. T minus 2t is minus t. So this is our z. Good. So our line is gamma of t, x is 4 minus t, y is t, z is 1 minus t. So far, so good, everybody. This is the parametric form of the line. If you really want to get like the equation of the line but without a t, you remember you can do x, y, z, and then you can solve for t, right? So x equals 4 minus t, then t equals x minus 4, y equals t, so t equals y, and then z is 1 minus t, then t is 1 minus z. Then you can have x minus 4 is y equals 1 minus z. So this is the equation of the line without the t. Okay, so this guy is the parametric form of the line. So far, so good, everybody. Okay, so now we have, in this video, we have talked about the plane in the space, and with a normal vector and a point on the plane, we can write down the equation of the plane. And we also learned about what happens if two planes are parallel or orthogonal, or we saw different cases like how to get the equation of the plane if we know some information of a line perpendicular to it or 3 points on it. Okay, and we also learned how to find the intersection of two planes. So far, so good, everybody. We know two planes, they can either parallel or they have an intersection in the line. And then three planes, it could be they are parallel or they intersect and get some lines, or they intersect and get a single point. Okay, so it's just like we solve the system of equations and we figure out whether there are solutions or one solutions or no solutions or infinite many solutions. So let's continue this session in video part B. See you soon.